Okay, so last lecture we discussed linear transformation, and let's continue with linear transformation, and we talk about its kernel, its range, and first we talk about whether a transformation is 1-1 or onto. Okay, so we first talk about a 1-1 transformation. If you remember from functions, that we say a function f is 1-1, right? If distinct elements has distinct images, that means if you have x1 is not equal to x2, if you have two distinct numbers, two distinct elements, so the value of function, if that is they must be different, right? And obviously vice versa. Sorry, it's f of x2. Or we check in a way that if f of x1 is equal to f of x2 for any two values in the domain x1 and x2, that implies that x1 is equal to x2. So we say the function is 1-1. You can check this one or you can check this one. Whichever is easy for you, you can check either one. Okay. So the same thing for linear transformation as well. We say a linear transformation L from a vector space V to W that will be 1-1 or 1-to-1 if there are two distinct numbers, distinct vectors in V, implies that their values under the transformation are different. L of V1 is not equal to L of V2. Or we go for the other one as well, that if L of V1 is equal to L of V2, that implies V1 should be same as V2. If that is the case for every possible value of V1 and V2, then we say the function is, or the transformation is 1-1. Otherwise, it will not be a 1-1. Let's do this example. We have a transformation from R2 to R2, and which is defined as L of U1, U2 is equal to U1 plus U2 and U1 minus U2. Okay. And now if you take two different points V1 and V2, such that L of V1 is equal to L of V2. If that implies that V1 is equal to V2, then we say that L is 1-1. If that is not the case, then we say L is not 1-1. So you see, L of V1, that means V1 plus V2, V1 minus V2. And L of V2 is similarly V1 plus V2, and this one is V1 minus V2. Right? If you find L of V1, what will be L of V1? See, V1 has a components U1, U2. So that will be by definition from here, the components are U1, U2, so you will take U1 plus U2 and U1 minus U2. Okay. And L of V2 will be, as you see, the components of V2 are V1 and new 1, new 2, whatever you call it. So it will be new 1 plus new 2 and new 1 minus new 2. Okay. So if L of V1 is equal to L of V2, it means these two vectors will be same. So the corresponding component will be same. So first component is equal to first component of the second, and second component should be same as second component. Now, if you solve these two things, you see from here U1 plus U2, that is equal to V1 plus V2. If you add these two together, U2 cancel, V2 cancel, we get 2U1 is equal to 2V1, implies U1 is equal to V1. Now U1 is equal to V1, and if you subtract that, these two will be cancelled and these two will be cancelled. We get 2U2 is equal to V2, implies U2 is equal to V2. So if U1 is equal to V1 and U2 is equal to V2, so V1 should be same as V2. This implies that V1 is equal to V2, which means L is 1-1. right? So that means L is 1, 1. If you consider that projection and we want to say whether this function is 1, 1 or not, so in that case we take a counter example. You see, if we take L of 1, 3, 3, it will be 1, 3, and L of 1, 3 minus 2, it will also be 1, 3. We are having two different vectors, but their transformation is what? That is same. Yeah, I started recording in section B, so I'll sharing that recording to everyone. Okay. Recording मा पर section B के start करे दे न यो recording बा की गया अब टोल सर बया share को मगा same recording बा हाँ. Okay, so in this case you see if you want to find L of 1, 3, 3, now we see by definition what would be the value? The value we see, it is defined as you take only the first two components. So that becomes 1, 3. And similarly, if you find transformation of 1, 3, 2 or whatever, so that will give you again 1, 3. You see, so these two are different, aren't they? 1, 3, 3 and 1, 3, 2, they are different, but their image, their output is what? Same. So whenever that's the case, the function will not be 1, 1. So this function is what? This is not 1, 1. Because for two different values of u, u1, u2, we are getting same results. We are getting same output. So this transformation is not 1, 1. Okay. Right. Next, we talk about kernel of a transformation. Okay. The kernel of transformation contains those elements of V for which L of V is 0. Right? Kernel of L, which is denoted by KERL, this contains those elements of V belongs to V, such that L of V is equal to 0. Obviously, this 0 will be element of the second vector space because outputs are in the W, inputs will be in V. Okay, so all vectors for which L of V is 0, that will be what? That will be the kernel of L. This is an example. You see, if you take L from R3 to R2, which is defined earlier, that's again a projection 1. So L of 0, 0, 2, that will be 0, 0. L of 0, 0, 4, that will be 0, 0, and so on. So all those vectors whose first two components are 0, that would belong to the kernel. Right? So kernel of this transformation will contains all vectors of the form. You see, the first component should be 0, second component should be 0, and you may have any component, the fourth one, the third one, sorry, where A belongs to R. So that's the kernel of this transformation L. And you see, kernel of L contains all elements of V. So kernel of L will be a subspace of V. And if kernel of L that contains only identity element, if kernel of L, it contains only identity element, in that case we say the transformation will be 1, 1. From here in this theorem, you can see that kernel of L, that is subspace of V, whereas L is 1, 1 if and only if kernel of L is containing only one element. This is another way to check whether a function is a transformation is 1, 1 or not. That can be done by checking whether its kernel is containing only 0 element or it contains some more elements as well. Okay, that's good. Let's suppose we are given this transformation from P2 to real number. Yeah. Say again. Chasa tapuso ko. Why can I ask? Okay. जी हिकमतुल्लाह वाया. Okay. Well, let's suppose we are given a transformation L, that is P2 to R real numbers, and that is defined as L of AT square plus BT plus C, which gives you integral of that polynomial. You have to integrate that polynomial from 0 to 1. Now we need to check what is the kernel, what is the dimension of kernel, and then is L 1 to 1? Okay. So we need to check this thing. Keeping in mind, if kernel of L that is not containing only identity element, that is, it is dimension greater than 0, so we say it is not 1, 1. Okay, so we first find kernel of it. So what do we do? For kernel, you take one vector AT square plus BT plus C, then L of V becomes what? Integral of this one, equating that to 0. Okay, so L of V, which is equal to this one, and that implies equal to 0. So C is equal to minus A by 3 minus B by 2. So all the vectors in kernel will be of the form AT square plus BT plus minus A by 3 minus B by 3, where A are any real numbers. Okay, we'll be taking what will be for kernel. What do? We take L of V to be 0. So L of V is 0. I'm doing it again. L is defined as integral from 0 to 1. Okay, let me do that. L of V is equal to 0, and V is obviously a polynomial, so that is integral from 0 to 1 AT square plus BT plus C is equal to dt is equal to 0. So this is our V. Okay, and if you integrate this one, you know how to integrate it. Integral of AT square will be AT cubed by 3 BT square by 2 plus CT, and we put limits from 0 to 1, that is equal to 0. If you put t equal to 1 here, so we get A by 3 plus B by 2 plus C minus 0 is equal to 0. From here we have C is equal to minus A by 3 minus B by 2. we have taken V vector, which is AT square plus BT plus C. Now C would be replaced with this thing, minus A by 3 minus B by 2. So these are the vectors which will belong to kernel. Kernel of L contains those polynomials where C is equal to minus A by 3 minus B by 2. Now to find basis of it, what do? If you remember, we were combining A's together and B's together. If you do these things, what would happen? You will take AT square minus 1 by 3 plus B into T minus 1 by 2. We combine these two together and these together. So these are the vectors which belong to the basis. That is, S is equal to T square minus 1 by 3 and T minus 1 by 2. That is the basis for kernel, which is the second part of it. And what is the dimension of it? That's the second part, because for dimension, we need to find first basis. So this is the basis. Dimension is what? How many elements do we have in the basis? There are 2 elements we are having in the basis. So dimension is what? Dimension of kernel, that is equal to 2. And if dimension of kernel is greater than 1, okay, we say the function is not 1, 1. You see, you can see here, because if the dimension is not equal to 0, in that case, it will be what? It will be not 1, 1. So dimension is 2, therefore this function is not 1, 1. Okay, next we talk about range of L. We say an element belongs to range of L. Is someone asking some questions or what? No? Okay, let me take attendance one time again. I don't take attendance again and again. I'm quiet because I'm taking attendance, right? Yeah, all these attendance will be in one file. So if you want to check your attendance online, there will be 3 sheets in the file, so you can check corresponding yours one, right? The Senevi Tasso as a manum Pakinista, the Oda Pakinista, the Dadreva section of Payo file Kiwi. Lande but tabs Pakiraja tab Kebagori. Okay, I'm explaining this thing by example. I don't know you will understand it or not. If you take an element from W for a linear transformation L from V to W, you will take one element from W and you would find whether L of V is equal to W or not for some V and V, right? For some V belongs to V, if L of V that becomes equal to W, then we say the function is onto, right? Generally we say range, if that range is equal to W, the function will be onto, which can be checked by this way. You take an element from W. If there exists V in V such that L of V is W for some V in V, then it will be what? It will be onto. You see, the way we do it is straightforward. Let's suppose again we consider that projection one. So projection is what? It is L from R3 to R2. You remember? This is R3 to R2, and it was defined as L of V1, V2, V3 that is equal to, come on, that's only V1, V2, because it projects a vector from R3 into R2. We would check whether it is a 1 onto or not. For that, what do? We take an element on R2. An element of R2 is what? AB. It's an order pair. We take AB belongs to R2, and we say, let's suppose this is equal to what? L of V1, V2, V3 that is equal to AB. We equate that to AB. Now by definition, V1, V2, this becomes what? L of V1, V2 is what? That is only V1, V2 by definition. So that is equal to AB, which means V1 is equal to A and V2 is equal to B. Now, if the system has solution for V1, V2, so which is obviously this, in this case, we found the values of V1 and V2. If you could find the values of V1, V2, then we say it is onto. If you couldn't find solution of this system, we say no, it is not onto. So here in this case, it is onto because we found the values of V1 in it. The same thing here. You take an element, any real number, okay, and equate that to this one. So you see, C is equal to R in this case. If you take A is equal to B equal to 0, so again L is onto. Okay, let's do this example now again. See, L is from R3 to R3, which is defined as that same thing which is we discussed earlier. LU is equal to A times U, where A is obviously a standard matrix of linear transformation. This is A, this is U, and so on. So we check, is L onto? Find the basis for the range, find kernel of L, and then is L 1 to 1 or not? Okay. So there's two ways to check whether L is onto or not. One way is that you should take one element from R3 and put that value here with this one, and then solve the system for that equation. If it has solution, then it's onto. If it's not solution, then we say no. That's one way to do it. The other way is if basis for the range, if that is what? That is equal to the basis of R3, it will be onto. Otherwise, it will be not onto. I think that's the first method is okay. That's easy. You take one element from R3. As I said, you take elements of R3 has got the form A, B, C. Okay. And we assume that L of V is equal to A, B, C. So L of V is what? It is defined in this way. We get a matrix 1 0 1 1 1 2 2 1 3, and we have U1 U2 U3 equal to ABC. Now you see we get a system of equations A, B, C. Now if this system has solutions, you will go for what? You will go for augmented matrix. You know how to take it. We'll consider A, B, augmented matrix. It will be the same matrix 1 0 1 A, 1 1 2 B, and 2 1 3 C. Now if this system has solution, whatever unique solution or many solution, so we say yes, it is onto. But if it has no solution, then obviously no. Okay, so yeah, in this case it is converted into echelon form, and we get what? 0 0 and 0. It means the system has no solution, therefore the function is not onto. You see, it is not onto. The second part, what do? We want to find basis for the range. You need to learn this one. This is a new thing. So how do you find basis? If you could separate these things together, you see V1 will be going with column 1, V2 will be going with column 2, and V3 will be going with column 3. This is the way we multiplied. If you see, we multiplied this in this way as well. V1 with first column, V2 with second column, V3 with third column. So the first column, second column, third column, we get this spanning set 1 1 2 0 1 1 and then 1 2 3. Okay, but now whether it is a basis or not, the how do we check whether it's basis or not? Obviously you will be going for checking whether they are independent or dependent, right? They are basically dependent, so we do what? We put them in column 0 1 1 1 2 3. How did I know that these are dependent? You see, if you add these two vectors together, 1 plus 0, that is 1, 1 plus 1, that is 2, 2 plus 1, that is 3. So the third vector is a linear combination of these two vectors. It means they are dependent, right? So how do you find a basis for it? As we have done that in last lecture, we have three vectors which span the complete space, and then you are looking for a basis, so we convert that into echelon form and going for the leadings one. Okay, so we are having these two vectors only, first one and second one, because from here you see that the echelon form of this matrix, so this row is completely zero, so one leading is here and the other leading is here, so we will take the first vector and second vector. The basis for it will be the first one and second one, therefore dimension is what? That is 2. Dimension of the range is 2. And dimension of R3 is 3. Both dimensions are not same, therefore we say it is not onto. Okay, if you want to find, अच्छा वाला mic on दिलक बंद कर यार. बैदार अहमद. Okay, so for finding kernel, what do? We take L of V equal to 0. You will do everything same, right? What would you do for finding kernel? You would simply replace A, B, C with 0. If you replace this A, B, C with 0 for finding kernel, what would happen? We have 1, 0, 1, and then we have 0, 1, and 1. And then the last one is 0, obviously. And the last row becomes 0, 0, 0. Okay, so we find solution of this homogeneous system. The last equation give you what? That is, you see, u1, u2 plus u3 is equal to 0. And by introducing a free variable u3 is equal to r, so u2 is equal to minus r. And the first row is giving you again u1 plus u3 is equal to r is equal to 0, which give you u1 is equal to r minus r. So we are having that u vector, which will be minus r, that is minus r and then r. So this is basically the kernel. Kernel will contain all vectors of this form. And how do you find basis for kernel? You simply take r common out of it. So for basis, if you take common out of it, what do we have? We have minus 1, 1, and minus 1 and 1. So that will form a basis then. Its basis contains only one element. So dimension of its kernel is what? That is 1. Now, whether it's 1, 1 or not, it is not 1, 1 because dimension of kernel is not 0. Dimension of kernel is 1. So obviously it is not 1, 1. So I hope you learned these things. This is another example. You can find basis for range of L. So how do we do? You would separate all these things. You would say, right, u1, 0, u1, right, plus u2, 0, 0. Next one is 0, u3, u3. Next one is u0, u4, and 0. And then you're taking all these common, so we get that's a sampling, that's a sorry, what do you call it, spanning set. And then you would check whether these vectors are linearly dependent or independent. Okay, so you would put these in columns, reduced echelon form, and then taking the leading entries. See 1, 1, and 1. So you take only first three vectors, this one, and this one. The umaga shede chekamga last lecture ke kadeo. Musala spanning set rashi, obya mungda chekau che da basis jodai, the basis basavi, nagamunga columns ke walu, echelon form to convert ku, and we take the leading ones. Right? So you see this is 1, this is 1, and this is 1. It's a basis for a range. Okay, so let's move to exercise. Baki suna pray de bas kafi de. Again, it's the same thing. Find basis for kernel, find basis for range, and then verify theorem something. Theorem 6.6. What is 6.6? Let's check it out. It's important. Yeah, theorem 6.6 says dimension of kernel of L plus dimension of range of L, that is equal to dimension of V. If L is a yes. Then plus chaval as mic on ya bazari me com class na ha. So you should remember this thing. This is a theorem that dimension of kernel of L and dimension of range of L that is equal to dimension of the domain. Okay. So keep this thing in mind. Right. So we move to the exercise then. So can you do these questions? Question number 1. You see L is given from R2 to R2 by linear transformation defined by this one. Is 0 2 in kernel of L? You would check whether it is giving 0 or not. So if you find L of 0 2, L of 0 2 will be what? You see the first one is coming U1 and the second one becoming 0. So it is in the kernel. Okay. Is it belonging to kernel? You would check whether L of 2 2 is 0 0. But in this case, no. L of 2 2 will be 2 0. L of 3 0 will be 3 0. L of 3 2 will be 3 0. So these three don't belong to the kernel. This one belongs to the kernel. Now any vectors whose first component is what? Whose first component is 0 will belong to the kernel. Right? And in this case, kernel of L will be what? It will contain all vectors of the form whose first component is 0. So you take 0a, where a is any real number. Because if you find kernel of this, it will give you 0 0. And what about the range? A range contains all vectors whose second component is 0. Okay, so we discussed all these things. So do question number 1, 2, 3. And let me check which are important. 1, 2, 3, 4, 5, 6, 7, 8, 9. So do up to question number 16. Okay. Do question number up to question number 16. From 1 to 16. You should practice these questions. If you have any question, you can obviously ask me then. Okay, let's move to the next chapter, that is Eigenvalues and Eigenvectors. Legdama to which three assignments among Shavi diga na? Your physical assignment te odwa online Shavi, right? Okay, then okay. Right, so we talk about eigenvalues and eigenvectors. So if you remember, we have discussed a bit earlier and in last lecture, there were some dilation and contraction. Right? So that concept is basically related to eigenvalues and eigenvectors. Okay, so let's define it. Forget about the starting things. We start from here. We say if we have a matrix A, forget about this transformation L and stuff like that. We go directly to the eigenvalues and eigenvectors of a matrix. We don't talk about this transformation, right? I don't know why they're talking about these things. We have something like that in here. Okay, so we discussed this one. These are transformations. We discuss eigenvalues, eigenvectors for a matrix. Forget about these things, okay? Yeah, from here, it's too many things which are not necessary. Okay, from here we can discuss it. If you want to find eigenvalues and eigenvectors of a matrix, we'll be given a matrix. Eigenvalues and eigenvectors. Let's suppose we have a square matrix. The first thing is a matrix must be square. M cross M or N cross N matrix. Be a square matrix. Then we say a number lambda will be eigenvalue will be eigenvalue of matrix A if there exists non-zero vector there exists x which is not equal to 0 such that A multiplied by x is equal to lambda multiplied by x, right? For a square matrix A, if there exists x, which is a vector of the form, obviously it contains x1, x2, up to xm. If the matrix order is m cross m, so this vector will be having size m cross 1. Mean to say, if we have a 2 cross 2 matrix, A is 2 cross 2 matrix, then it will be x1, x2. If it is 3 cross 3, it will be x1, x2, and x3. Right? So if you could find if there exists a non-zero vector, right, x such that Ax is equal to lambda x, then we say that it is what? This lambda is the eigenvalue and x is what? That is the corresponding eigenvector. Okay, that is the corresponding eigenvector. Now, how do we do that? It's a very simple thing. This is a definition of eigenvalues and eigenvector. Now, to find it, what do we do? To find eigenvalues, so we take how to find it. It's really very hard for me to type because I don't know, it's not writing properly. So what do? We simply take determinant of given matrix A minus lambda times identity matrix and equate this determinant to 0. This is known as characteristic equation. This is known as characteristic equation. And solution of this characteristic equation will give you eigenvalues. Okay. Yeah. Solution of this equation will give you eigenvalue, and then by putting the value of lambda and a in this equation, we get homogeneous system of equation, and homogeneous system of equation solution will give you eigenvectors. Okay, so how do we do that? I'm doing a simple example of 2 cross 2. Keeping in mind, if you have a 2 cross 2 matrix, the characteristic equation will be of degree 2. But if we have 3 cross 3 matrix, the characteristic equation will be of degree 3. Generally, if we have n cross n matrix, the characteristic equation will be of degree n, right? And it's becoming harder and harder when you are increasing the degree of characteristic polynomial or characteristic equation. Okay, we see it say find eigenvalues and eigenvectors of this matrix 1 1. This is 1 1 1 minus 2 4. So as I said, we'll be looking for what? For a vector x1 x2 such that a into x1 x2, this is matrix A, is equal to this one. As I said, we find first what? A minus lambda I. The matrix A is what? That is, we find first A minus lambda I. I is the corresponding identity matrix. The matrix A is what? That is 1 1 minus 2 4 minus lambda I, means lambda 0 0 and lambda. We simplify it, we get what? It is 1 minus lambda 1 minus 0 minus 2 and 4 minus lambda. Now we take determinant of this matrix A minus lambda I, equate that to 0, which means, you see, determinant of lambda minus 1 or 1 minus lambda, doesn't matter, minus 1 2 lambda minus 1. If you simplify it, we get lambda square minus 5 lambda plus 6 is equal to 0, which give you lambda is equal to 2 and lambda is equal to 3. So these are the eigenvalues. Lambda is equal to 2 and lambda equal to 3 are the eigenvalues, right? And then you would do what? You would simply put the value of lambda here in this equation. For lambda equal to 2, we find solution of this homogeneous system of equation, this one. Obviously there will be a free variable involved in it, right? Any arbitrary free variable will be introduced here. I hope you know how to find solution of homogeneous system of equations. Okay, and for lambda equal to 3, you would find another solution of another system of equation. You get this system of equation. So one eigenvector is this one, and another one is found here, that is this one. You can simply replace it by s by 1, so we get 1 and 2 here, or we put s equal to 2 here. So we found eigenvalues and eigenvectors in this case. Okay, so a simple thing, you would first find a minus lambda I or lambda I minus a, doesn't matter. You can take either one. In this case here they are saying lambda I minus a is equal to 0. You take determinant of this equal to 0. I explained a minus lambda I, doesn't matter. You can take either one. That's same thing. And then you find the roots and so on. So let's do again another example for 3 cross 3 matrix. Find eigenvalues of this matrix or whatever, characteristic polynomial or characteristic equation. We see lambda I minus a, that is lambda minus 1. Lambda I minus a basically means subtracting lambda from the diagonal entries of matrix A. You can directly take 1 minus lambda, 0 minus lambda, 5 minus lambda, and the rest is same. Take as determinant and equate that to 0. Okay. Yeah, the same thing. You find eigenvalues and eigenvectors in 3 cross 3. In this case, say compute eigenvalues and associated eigenvectors of this matrix 0, 0, 3, 1, 0, minus 1. So you first find characteristic polynomial, okay, and then we equate that to 0. You can use calculator to find roots of this cubic or quadratic polynomial. You should use calculator, right? So we get these eigenvalues 3, iota, and minus iota. So we first take the system of equation for lambda is equal to 3 by putting 3 here multiplied with x1, x2, x3 equal to 0 to have corresponding homogeneous system of equations. And that give you this eigenvector. And then we take the other one for iota and solve the system. We get this complex eigenvector. Similarly, this one is also a complex eigenvector. There's another one, and so on. So you do some questions here. You do question number 5, 6, 7, and question 5 to 9. Do question 5 to 9. 5, 6, 7, 8, 9. Which you have to find either characteristic polynomial or you have to find eigenvectors and eigenvalues. You should know that. Do question number 5 to question number 9. Okay, there is something more as well, which is obviously diagonalization. That is a bit important, but it's a bit lengthy process as well, because we need to find eigenvalues, you need to find eigenvectors, and need to find a matrix and then multiplying by the inverse of the matrix. It's a bit lengthy, and obviously, yeah, it cannot be done by through online class, right? देखिए काफ़ी राइटिंग भी होगा इसने की गया है ना. So do up to exercise 8.7.1. Forget about diagonalization at the moment. If you have any question, you can ask. What do you mean guide about the exam? There might be one question in the course which is before midterm, and the remaining paper will be in the course we have done after midterm.
Sir, मिड के बाद जो कोर्स है उसमें पेपर.
Sorry?
सर मिड के बाद जो कोर्स है उसमें पेपर सर आने से.
या उसमें भी होगा, मिड से पहले वाले पार्ट में भी होगा ना
सर वो.
Yeah, you cannot forget that, because if you have forgotten that, then obviously you cannot do these questions as well. Because before midterm it was all about echelon form, reduced echelon form, solution of system of equation, homogeneous system, non-homogeneous. We are doing still the same thing here as well. You see, in finding eigenvectors, we were solving homogeneous system of equations and checking whether it belongs to a kernel or things like that. So all of them are what? Solution of echelon for solution of homogeneous system of equations are converting into echelon and reduced echelon form. Yeah.
Excuse me, sir.
Yeah, but quizzes were online. Both there we have two quizzes, and both were online. And we will be having another quiz tomorrow, maybe on Friday, which is also online. So I think there is no excuse of it. And we are having 2 assignments online, and one was physical. So one is not affecting anything. It's a very minor. So we should
Sir,
have attempted. Okay.
excuse me, sir.
Yeah.
Sir, mong dati college sir, chairman ta melo ko sir che mong la preparation na para yung weeks lagi sir sa kada course dir jatta sir divi mande sir.
Yeah, you should talk one person at one time, because Muhammad Hassan is also talking and the other guy is also talking. Okay, the bulk cover hai so cover hai.
Sir mong chairman sir ta mail college sir che mong na preparation na para 1 week lagi sir.
It's a policy thing. Chairman cannot do anything. It's the university matter. It's not a chairman matter. You are having 1 week. Obviously, Eid week is for you guys. That's why we are taking double classes. We took extra class last week. We are taking extra class today as well. So,
Sir di ba mong sir dir jatta sa da mong cover na ko subject sundi.
no, تين was that time they were online exam. They were taking. Okay, so there will be a quiz in linear transformation and eigenvalues and eigenvectors. It's up to you. Are you ready tomorrow or on Friday? And Friday, what time? Friday
Sir,
is better. Okay, what
sir
time?
Saturday ठीक है sir Saturday.
Friday, what time? Okay, so it will be 8 p.m. Friday. Quiz number 3, it will be Friday, 8 p.m. Okay. So, okay, thank you. I'm stopping recording, and then all of you can leave the class.